Good evening, ladies and gentlemen. With some pride and pleasure, I can say that we are sitting in the front line of the battle against the global warming. I mean, there's no other continent that is so dedicated to combat this threat. Some of people even are making fun of it, but I hope we are not this kind of people. So, each of us has to contribute, of course, but the spotlight is on industry, and among the industry, of course, energetics is the segment that's where we expect the most contribution to win this battle. So today we brought to you a special guest, Dr. Dejan Paravan. He is a representative of one of the biggest Slovenian electro-energy segment company. And just to inform you who is our guest, I'm gonna read you his CV now. Dr. Dejan Paravan is Chief Innovation Officer at GEN-E Group, one of the most innovative and fastest growing players on the European energy market. Dr. Paravan is responsible for strategic development of new business models and transitioning energy sector. Dr. Paravan received his diploma engineer and PhD degree from the Faculty of Electrical Engineering, University of Ljubljana in 1999 and 2004. During his PhD studies, he was employed as a young researcher in Energy Policy Lab at the same university. For research reasons, he visited Siemens Research Center in Erlangen and several times Iowa State University in USA. He was also on a working visit at the company Decision System International at Atlanta, USA, as a technical consultant for implementation of EPRI software for short-term load forecasting at system operators in California, New Mexico, and Brazil. He took part in several research and applied projects for Slovenian energy companies and projects in the EU Framework Program. After finishing his PhD, he joined the team which established GEN-E company. Since then, he took several managerial positions in the field of electricity sales and electricity trading. Dr. Paravan started the retail electricity business within the group in Slovenia. In 2005 and 2006, he was CEO of Istrabenz Gorenje and member of management board at Austrian Power Vertriebs. In 2012, he was one of the key team members at GEN-E when entering gas market. Since 2015, Dr. Paravan is actively involved in development of new energy services within GEN-E, that's self-consumption with solar PV, demand response aggregation, e-mobility, energy management, and so on. Dr. Paravan is a member of International Council of Large Electrical Networks, president of the study committee at Slovenian Forum of Electroenergetics. He was member of organizing committees of several international conferences and co-author of more than 50 scientific and technical papers and conference contributions. So this is our guest, and I think he deserves applause, and I invite him to take the stage.
Thank you for the invitation. I'm glad to be here and to present this lecture. I have structured the lecture into 4 main parts. First, speaking a little bit about energy and global warming, then about energy transition, and then a little bit about our group, and especially finishing with what are our innovation activities in the group and what innovation projects are we developing. Today, when I opened the newspaper, local newspaper, this picture was in it, and actually this young lady is the reason why global warming and the urge for making solution to global warming is today very present, and I believe that there are very little people on Earth who doubt in what's happening to the Earth. Why is this so important, and why is energy here so important? Is because energy is one of the main sources of green gas emissions. As we see, roughly 25% of CO2 emissions happen due to production of electricity out of primary sources, and then there are different other sectors which also produce CO2 out of energy. Now, if we know that energy is reason for CO2 and we need to lower CO2, the answer would be very simple, just to lower the demand. But this is a kind of tricky, because there is a very strong correlation between development and use of energy. So if we want to develop, we need to increase the use of energy. And this is this graph showing that the correlation is quite evident. Another graph which shows a similar situation, and this is even a nonlinear dependency between these two variables, shows also that here at the beginning, here that at the beginnings we have 80% of the population in the world still uses relatively little energy, and they are underdeveloped. It is totally obvious that all these people here are striving to develop. So we cannot tell them, listen, because of global warming, you cannot use energy, so you cannot develop. And this is actually the other part of the coin, why this problem is such a huge problem. As a result, by developing, this is the total primary energy consumption in last 200 years, and we see that the consumption on the world is steadily growing. And obvious it is that this growth will continue, and we cannot stop it just overnight. If you looked how it is divided, so which energy sources do we use, we can see that the three main parts are coal, crude oil, and natural gas, which account roughly at 85% of total energy demand. And these fossil fuels are the primary source for CO2, obviously. And although we listen a lot of renewables and sustainable production and so on, and although the changing are happening, still the renewables part is very, very tiny, very, very small. Now, with these fossil fuels, there are again two problems. One, which is obvious, is the CO2 emissions. The second, which was for first time noticed during the energy crisis in 70s of last century, is whether do we have these energy sources enough. At that period was established by Mr. Hubert a peak oil curve, which was a hypothesis that actually the oil production will peak, and he predicted actually how the production of oil will peak and then start falling. Actually, this curve reflected here, and the forecast was quite good, but then with the shale gas and shale oil, because we developed new ways of utilizing and sourcing oil, the production increased in US again. Now, we could discuss, whether we have enough of fossil fuels or not, but according to BP, the statistics says that those reserves which we know, and if we take in consideration the energy demand of, I believe it's from 2015, we have oil for roughly 50 years, natural gas for 50 years, and coal for 150 years. Now, let's think about all these fossil fuels were made by, in crust of the earth, by microorganisms which were dead, and the procedure of forming fossil fuels took several millions years. The estimation is about 300 million years, and we, in 100 years or 200 years of utilizing them, we are already thinking, okay, did we run out of that or what? So also from this perspective, it is totally clear that this is not a sustainable use of energy. We use this fossil fuel to develop, and actually the fossil fuels are very useful to develop because they are very dense, you can store them, so it's a lot of practical usability. But from the sustainability point of view, how many of those sources are, and how they affect our environment are totally non-sustainable. So there is totally no question that we need to transition from utilization of fossil fuel to other more sustainable sources. So for that reasons, in the energy sector, we are talking about how to transition away from fossil fuels. This is again from BP, which is a good source of information. They produce different scenarios how to differentiate and how to transition to different sources of energy in order to lower the green gas emissions into the environment. And here are the 4 scenarios for 2040. So let's look at the most aggressive from their perspective. And you can see that the total consumption of energy will still be higher than what it is today. And that actually fossil fuels, oil, gas, and coal will still represent, according to their expectation, more than 50% of total energy use. So there is no way that we could transition from fossil fuel just by night. The next trend in energy is that we are transitioning from utilization of other primary sources toward electricity. Why? Because we have different options to produce electricity from renewables, and also because electricity is very good kind of energy because of the utilization in processes. So here we can see that the utilization of primary energy for electricity production will increase, and that in electricity production, the share of renewables will go, or is expected to increase a lot during next 20, 30 years. If we just take a look at how we are doing, if in last few years the whole consumption of energy the growth was declining, so it was still increasing, but the piece of increase was declining. The year 2018 shows quite a remarkable growth of almost 3% of total energy use globally, which obviously produces and has effects towards the environment. So although all talks, although all kind of measures that we want to prevent global warming, the trend is still very clear, and it is not into the direction that we want that it should evolve. So now about energy transition. We want to transition away from fossil fuels, and this transition is nothing new, because if you look at the relative share of different primary energy sources, we see that these transitions over time happen all the time. So, for example, here, the share of coal in primary energy utilization was more than 50% just after year 1900, and then is steadily going down. What we want is that this small part here, which means renewable, so let's say nuclear, hydro, and renewables, these are the sustainable sources which don't have green gas effect. We want them to escalate and to take primary role into the supply of energy. How will affect this electricity business and the electricity sector? The main driver for this is not only willingness to save the planet, but it's actually the technology. The technology is, and all the development in technology is the one which is driving all this change. And of course, this shift will be gradual. And the technologies which are the most important are ICT, so information communication technologies, then technologies in energy sector like PV, battery storage, and so on, and technologies, developing technologies in transportation, especially electrification of transportation systems. As a result, there are new phases in energy. You know, energy business, especially power business, was always quite non-attractive. Today, this is not the case anymore. We have different new phases which produce fancy and very beautiful products and actually are surfing the wave of this energy transition. How the technology is evolving. Here is the graph. Pay attention on logarithmic scale. What is the actually very well-known correlation between how much you produce of a specific product and how the production cost will fall. Although the beginning of development of PV cells was in 70s, in last century, the cost of PV cells only from 2010 to 2018, so in those 8 years, fell by 80%. So it didn't fall to 80%, but by 80%, from 100 to 20. And it's still falling. And PV today, in many parts of the world, depending on what is the sunshine and so on, it's already the best and the cheapest way of producing electricity. One such country, for example, here in Europe, is Spain, where actually the system operators already have problems because of so many applications of new power plants which want to get connected to the grid. The next thing is the battery storage. The storage of energy is the holy grail of energy, electricity part, so the power sector. We cannot store electricity in big parts. This is the reason why I'm also very, very proud and very happy that the University of Nova Gorica developed new ways of how to store electricity. And the battery storage, again, is falling. The cost is falling. But also you can see that it was expected that in 2020, we will have the capability to store 3 minutes of the total consumption of electricity globally, okay? So still, the capability of storage electricity is still relatively small, and that's why this is one of the main challenges which will help transportation as also power system. How all these changing in environment are affecting our business is also seen from the electricity or the traditional electricity value chain, which was very simple. You produced and generated electricity, then there's transmission system, you transport it, then you distribute it, then you supply it to end consumers, and then consumers just consume it, and that's it. So now what's happening is that with all kinds of technologies, this one-way story is not anymore one-way story. So there is a lot of confusion here because electricity is flowing all kinds of directions, and especially here at the end customer side, it's happening a lot. Before, we just utilized a little bit of energy at home. Today, we have all kinds of appliances which affect our energy use. And the power system was made for this kind of value chain and not for this kind. So for that reason, there are a lot of issues and a lot of problems. Main players in energy sector do have problems with that. So those who don't cope with all these changes have huge problems. For example, here you see the evolution of stock price of two German companies, E.ON and RWE. These are the German champions, or at least they were. Only their profit in year 2008, so before the global crisis, was in tens of billions of euros, only the profit, okay? Today, they are in such trouble that basically they are merging together. So 1 year ago, they announced the merge, the biggest two energy companies, and this is actually, I believe, the last attempt to save those companies because they just cannot recover all these changes because they didn't adopt it to them. So on one hand, the traditional industry is having problems and need to change because of the change in environment. On the other hand, somebody else also needs to change. So all those who are or who have studied power engineering know very well what this is, and this is, you know, how we elected power engineers see the world. So this is how we see it when we go down the street. And for those who don't know, this sign here is the sign for the generator, so for the production of electricity. And this sign here is the sign of consumer, consuming the electricity. And we name this sign, and these are our customers actually, as loads. This is not joke, okay? Our clients are loads from the power perspective. And this is not because we would, you know, not respect them, but this is because that you understand how the power system was made. The power system was made that whatever you do here, we provide you electricity. Whatever you do with the socket, whatever you put in, the light will shine. So actually the reliability of the system was extremely good. Why we could do this? Because we had fossil fuels. Because with fossil fuels, we can store them, we can manage them, and this was, you know, we could do it. Now, if we put fossil fuels out, so those sources which we can manage, and put renewables in, solar, wind, which we cannot control, okay, we can lower them, but we cannot increase them if there is no sun, then we have problems. So that's why storage is so important. But since the whole equation is very difficult to solve, we need other solutions. So we need that these loads, these customers, change their behavior and that they become active customers, that they are aware of what they are doing and that they actually become part of the solution. So for that reason, we see a major change at the customer side, at the customer level. We see the change that the home of future will be much different than it is today. It will have a solar power plant for self-consumption. It will have electrified heating. It will have a battery storage, e-mobility card. Everything will be connected so that, you know, we will still have the whole all benefits and know how to work with managing the whole system. But we will allow somebody else to manage all these parts together. Now, if we change and we transition to this new power system, we have, of course, different challenges. That's why you will, I'm sure, read in newspapers, in blogs, and so on, a lot of debate. What makes sense, what doesn't make sense, you know, and there are a lot of myths associated with that. Why? Because, of course, if the environment is changing, we need to change also our way of thinking and our way of doing. And I will just name you a few examples how the whole thing will be affected. So, for example, here is first example. This is the standard load profile of consumption, and this is the case for California, okay? And this is typical consumption. It is also here in Slovenia very similar, that we have lower demand during the night, obviously, and then we have two peaks, one in the morning and one in the night, and this is what we need to cover with different energy sources. Now, when we add a lot of solar into the grid, the sun is produced here, and what we call this, if we subtract from the demand all renewables and all the power that just come into the grid, we have the result is the so-called residual demand, and this is the shape of the residual demand that is changing. And in extreme, we get a new curve, which is so-called duck curve, which has a huge gradient here, which somebody needs to follow. Either it can be storage or it can be other sources, and this is, from the system perspective, an issue. So we need to change how we operate the system in order to cope with that. Then there's another example of EV charging. This is, again, a topic that it explained a lot, also, you know, in cafes and so on. Okay, if I transition to an EV car, okay, how I will charge, you know, the whole power system will collapse, and so on, and so on, and so on. Now, let's make a calculation. So I said, okay, let's assume that I want to charge my electric car the same way I'm charging now the diesel car. So I went to the petrol station, and then I used my watch to measure that I refilled the full tank in roughly 1.5 minutes, so 90 seconds. If I calculate what is the value of energy in that those 60 liters of diesel, you can calculate it that this is roughly 0.6 megawatt hour of energy. Now, the average consumption in Slovenia of an average household, so house, is about 4 megawatt hours per annum. So only one diesel tank has 0.6 megawatt hour, okay? So you see why the fossil fuels are great for utilization, yeah? And if I divide now this energy with time so that I see, okay, what power I'm filling it, I get 24 megawatts, okay? So now if I go to the electric car, of course, because the electric car is at least three times more efficient than the normal car, I would need, if I want to charge the same amount of energy in the same time, I need to charge it with the same power, but because it is 3 times more efficient, I need 8 megawatts of power, okay? So now the question is, how much is 8 megawatts? This is the Soukan hydropower plant, so it's very here nearby. And the peaking capacity of this power plant, so when it operates at its maximum, and this is very rarely, it's not often, it's 32 megawatts. So if I want to charge a Tesla car the same way I'm charging a normal Audi, I can put 4 such cars and connect it to such power plant. Okay, so now what's the takeaway? First of all, you know, those who don't like this change would say, okay, the EV cars are bullshit. I mean, there is no way we can operate it to this. Or the other takeaway, my takeaway is that if I have stocks in a company who owns petrol station, I would sell them today, because we will not charge our EV cars at petrol station. That's my takeaway. We will need to change behavior. And this is all about. So if we understand the whole background behind, we we know how the environment will change, and we will develop new solutions how to cope with these challenges. There is a good study about effect of electric vehicles to the power grid, which was done by RTE. This is the system operator in France, and they simulated what or how would the expected fleet of electric vehicles in 2030 affect the power system. So here we have the demand, then we have here charging, and this was simulated if when you come at home or when you come to the office, you just plug in your electric car and you just charge it. We call them stupid charging, just charge it normally. So without any control. Then you have non-dispatchable renewables, and this is the residual curve. The more that the residual curve is shaky, the biggest problem is for the power system. If we implement 100% control of charging, so that we control when to charge, but at the end the car is at the level that the user wants, we see that we can put a little bit of energy into those other parts which are not problem, and we can see that we can already, levelize a little bit the whole curve. If we introduce also V2G, so that actually we utilize the electric vehicles as battery storage, so that they even help the grid, we can see that we come with a residual curve, which is even better than the normal demand. So not only that we don't harm the power system, we can help it. So again, we can see that if we implement and introduce electric vehicles in a wrong way, of course we can damage the whole system. If we can introduce it in the right way, we can even help it. So that's why it's so important that we change our way of thinking, and that we develop new ways of and new methodologies for how to develop the power system. Another quite interesting result from the same study was what is the cost of supply. Now, if the energy supply cost for, again, a standard car was estimated, this is the yearly cost, at 1,100 euros. Now, if you just transition to electric vehicle, the new cost will be less than 400 euros per year for the fuel. If we use special tariffs, this is reduced additionally to 250. If we reduce and we manage and control this charging, we can reduce it additionally. And at the end, if we come to the vehicle to grid, we can additionally reduce it, but this is limited because the current tariff structure is a deal breaker. So again, we will change the tariff structures because the tariff structure today is not made for future. And again, we will see that if you change the tariff structure, actually you can even gain because you help the system. And this is something that will actually happen in future and that will affect us in future. And of course, there will be new players who will develop all those services. Okay, so this is about energy transition and how the environment is changing, and now let's see how we are coping with that. Now, first few words about Genai. So we are energy trader and trading and energy supply company. We are supplying with electricity and gas and consumers, and we are operating in vast majority of European countries. We trade and sell electricity in the amount of more than 50 terawatt hours per year. So just for a comparison, the total consumption of Slovenia is roughly 12-13 terawatt hours. So we sell about 4 times the volume of Slovenia. And our revenues are more than 2 billion euros per year. We have almost 400,000 customers in different countries, and 3 main businesses. One is trading. This is, like trading with electricity on power exchange and so on. then supply of electricity to end customers, and we are adding a new pillar, which is called energy services. So we are developing new energy services which help our consumers to make the green transformation and to lower their CO2 footprint. So we are developing strictly services which help them to lower their impact to environment. How we do that and why actually the innovation is the main driver and the main part which we believe that can bring us success. So first of all, let's talk a little bit about innovation. So why we need so much innovation? So why is this so important? First of all, I believe that you heard about this VUCA word, that we live in VUCA world, which means this is an acronym for volatility, uncertainty, complexity, and ambiguity. And this is actually the world that we are in. And according to previous slides, I believe that you agree with me that a lot of things is changing. It's changing very fast, and there is a lot of uncertainty. So in such world where we are in, and also other businesses, the result of, for a company, how it will evolve if it is not innovating, is very clear. It will actually, with time, there is no future for such a company. Second, if we want to survive, we need to grow and utilizing sustaining innovation. So these small changes to our core business. Now, in many times also this is not enough. Why? Because the world is changing with exponential pace. And for that reason, we not only need to innovate, but we also need to put some effort in some special bets. So developing something totally new, because only sticking to what we currently have is again too risky for long-term survival and long-term sustainability of the business. So for that reason, we need to innovate, and we need to innovate in a smart way, where to put our resources. Why is this so important again? Because resources are limited. Yeah? We don't have limitless money to investigate all different options we have. So for that reason, we need to decide how much we invest, so how much money we put into innovation projects, and of course also where to invest. So for that reason, usually we do mapping of our innovation efforts, and this is one way of how we can look at it. On one dimension, we have technical competencies that we just leverage what we already have, or we need to develop new one. And the other is business models. Do we, improve the current business models, or we need to invent totally new? And then we see and we can map where we should strategically focus our innovation efforts. Another way of mapping innovation, and this is I like this way quite a lot, is whether we utilize existing products and services, or we develop new one, and we apply them to existing markets or to new markets. And again, we see here that we have core here, so this is our core business, our existing markets, existing products and services. Then slightly adapted, so adjacent part, and totally transformational. And again, when you are managing the company, you need to decide, okay, how much money will I invest where? These percentages, for example, are percentages of Google. So Google, which is one of, first one of the richest companies on the world and very innovative, they're investing only 10% into transformational activities, but still 70% into their core activities. So the money going into this new stuff here, it's relatively small. So we need to spend it very rationally and very efficiently. That's why we need to develop and design an innovation system so that we are very disciplined in doing all that. And the process is never linear. So we need to utilize a recursive process, and we need to iterate through this. And actually, the way of doing is very similar as in academia, as in research. So you make a hypothesis, then you do experiment, you measure it, you learn, and then you change the hypothesis and you iterate. So actually, what you all at academia do in let's say this startup world and the innovation space was just translated into it. So all this doing needs to be, I'm stressing this very, very carefully, needs to be very strategically oriented, disciplined. Accountability needs to be very high, because otherwise you'll, just spread your resources and lose money. And the result will be very poor. Of course, next big issue is which projects to select. Here, again, the whole procedure is very hard. And again, you need to develop special skills, how to decide with which projects to continue, which to abolish, which to kill, and so on. So if we, now I will show you some more cases, how we do this at Genai. So what we believe, or what we are stressing in, are three major trends on which we decide how to invest our resources and where to focus. The first one is digitalization. So we totally believe that we need to digitalize our business and produce data and then make added value out of the data. The second thing is the trend of electrification, that a lot of things will electrify. And the last thing is the trend of decarbonization, so that we want to clean our or lower our footprint, carbon footprint. Now, if we go step by step, what we do in terms of digitalization. So again, if you listen or if you read what the term digitalization means, each one has a slightly different explanation of it. So how we understand this, it's a little bit complex and actually incorporates all this. On one hand, we need to digitalize internal processes in order to optimize them and in order to automatize them. With this, we produce a lot of data. Okay, so we need to handle those data. And that's why we need a lot of smart people and new technologies and techniques how to manage those data. When speaking about digitalizations, many people say, okay, artificial intelligence, digitalization, this means that, people will not be needed anymore. Well, our experience is that with this process, we are just growing in the number of people, not lowering them down. So with all this, we can interact in a new way towards customers, again, producing data. We develop digital products and services, and at the end, all this needs to be reflected in new business models, because these are the ways how we bring benefit to customers and earn money for our stakeholders. Few examples. As energy trader, we, of course, need to bet where the prices will go. Now, we don't have a crystal ball, so that's why what we have is a lot of smart people who do a lot of analysis, probability analysis, and then we take decisions and strategies that we believe that have higher than 50% of a probability of success. For this reason, we need to have data. One source of data is how much water is in hydropower plant reservoirs. And this is a picture of one hydropower plant in Balkan area, where there are no data of how much water is in that reservoir. So what we did, because this information was valuable to us, our analytics guys made image recognition. So they acquired the satellite images, they take them every day down. They applied algorithms for image recognition. They calculate the surface of the river basin, and out of that they calculate how much water is in the river basin, how much energy could that power plant produce in next week, and that's how we predict what the price will be. And this is one way or one example how we utilize data analytics in that. Second example is that when doing the energy trading, there is a lot of sentiment in the market, okay? A lot of news and because people are still trading, and there are a lot of decisions which are based on sentiment. And the thesis here was, the hypothesis here was, okay, can we measure the sentiment? So can we scan the social networks for a certain keyword and try to figure out and calculate indicator which would show us, okay, where the price would turn and where it would go. So we do that for oil and utilize Twitter as a source of data, and then reproduce an indicator which would help us, okay, should we sell or should we buy this commodity in terms of, again, position and optimize our portfolios. As I already explained, because of all this, we are growing in number. By the end of this year, I believe we will be already 500 employees in the company. Not all this growth is due to digitalization, but majority part for sure. So with digitalization, we needed to establish new system. We needed to establish analytic BI departments and so on, how to cope with all those data, and that's why we needed to hire a lot of new smart people. The second trend is electrification of everything, which actually includes the electrification of transportation, then electrification of heating with heat pumps, industry, and relation to demand response, and of course battery storage, which we already mentioned quite a few times, that it's a very important part how we will solve the whole equation. Now with e-mobility, this is one project that we did together with two partners outside the company, so on the principles of open innovation. One was Metron Institute, which is actually one of the pioneers of e-mobility in Slovenia, and NET is the company who is specialized in blockchain technologies. So what we did here is that we said, okay, can we produce an autonomous EV charging station which would use blockchain technologies so that the blockchain would be utilized into communication of devices and deciding who will sell electricity to whom. So what we did is that we did an off-grid system comprised of PV power plant, battery storage, which is here inside, charging station, a car which was hacked. So this smart here is a V2G car, so it can also put energy from the battery back to the grid. And when a new car comes here and the user authenticates at this charging station, then he just says, okay, I want to fill car by that much. And then all these machines, they trade the electricity, decide who will give electricity to this card, and all the transactions are made automatically. So this was one attempt when we wanted to better understand the blockchain technologies, and we said, okay, let's do a pilot in order to investigate what are the barriers and how the whole thing functions. Another thing, or another project, is our internal sustainable mobility project. Again, before we go outside and develop services for end consumers, of course we need to test and try and gain experiences in-house. So what we did is that we took the decision that we will change all our fleet with EV cars, and today we have more than 30 electric vehicles in our fleet, and we are changing it and increasing additionally. And we develop different applications that people or our employees can share those cars, can share the rides, can rent the cars for the weekends and so on, in order that they gain the experiences how to utilize the electric cars. We equipped all our offices with EV charging stations. We established connectivity so that we monitor charging, that we control charging, and that we develop different solutions which we finally bring to new products and then bring them to the market. Next thing is our heat pumps. Again, heat pumps are quite a tricky problem. Why? Because compared or in alternative to e-mobility, heat pumps are a major problem for the grid, because when there will be bad weather and cold weather, everybody in the country will need to heat and consume electricity, and actually at that point a spike will be produced. Okay, so for that reason we need to manage that spike somehow. So that's why we again established a pilot. We equipped a pilot test of, 30 customers with controllers of their heat pumps. We are monitoring them and then playing with their consumption. And what you realize is that heat pumps are extremely stupid machines, okay? They're so stupid that they see only what is the outside temperature and what is the internal temperature, and that's it. They don't see the tariffs, they don't see what is the grid status, they don't see whether it is in the morning that you will come in, no predictability inside, nothing. So again, a lot of opportunity space to improve and to establish some smart controlling of those devices, which should take into the consideration also the environment around them, and again, produce solutions rather than problems. Next thing is demand response. For several years, we have a virtual power plant. What is this? This is a software which connects to different users who have the capability of adapting their demand. So that this is the demand response. So we installed those controllers or those industrial sites who have this capability. We link them into our system, and then we establish actually a virtual power plant which can produce the same effect as a similar power plant to the system. And then we are selling those flexibility services into the market towards the system operator for ancillary services and so on. We are also looking further for how to solve the issues which are at the side of the customers. If you remember, when I was showing the value chain, I was showing also the part behind the meter, so which is happening at the customer side. Now, the traditional power engineers see this as a threat. Why? Because they see different interaction of customers towards the grid. Now, our position or our hypothesis or our goal is that we solve most of the issues already at the site. And that's why, again, with Metron Institute, we developed this pilot. This is their production facility. It's small, but it's functioning, and it's on the east part of Slovenia. And actually what they did and what we did here together was that we put on the roof solar panels, so we increased the self-consumption of the facility. We put it energy storage. We put it charging stations, because they have a lot of electric vehicles there. And what we achieved was that compared to the initial state, we even lower the peak capacity or the peak power in the connections toward the grid. So not only that we, that we limit the damage or the influence towards the grid, we have here a living proof that we even lower the interaction towards the grid. And although installing, intermittent renewable sources and so on, we managed to do that. The third trend where we again develop different solution is devoted to decarbonization. Here we are betting on sun and on self-consumption with solar PV. Why? Because especially for Slovenia, we have a lot of roofs, whether this is residential, whether it is a multi-apartment building or industrial objects, and all those roofs are there to put solar on. And we actually don't harm any environment compared to some other installations. And that's why we developed products which we are commercializing already for individuals, for apartment buildings. Actually, this is the first and still the only energy community in Slovenia. It's in Jesenice, where we are supplying more than 20 apartments with a power plant on the roof. And their return, return on investment here is something like 7 or 8 years for the power plant, or this solar power plant, which has a life cycle of 30 years. And of course, the industrial objects, we are also doing projects there, developing products, how to finance them, how to solve all the solutions. And the result of all that is that we installed in Slovenia more than 1,000 solar power plants, and we are actually managing and monitoring all these resources in Slovenia. So this was an explanation of how we see or how we look at the energy system, at the power sector, where we see the major trends, and how we utilize innovation to produce new solutions, new products, which help our customers to lower their carbon footprint. And that's why we believe that we have the mission to help transition to zero carbon future. Thank you very much.
Thank you very much. We are happy to see that you are working a lot towards better future for us, to avoid us boiling into this planet. So now I would like to invite you, ladies and gentlemen, to ask everything what you ever wanted to know about energy sector. Please.
Yeah, thanks a lot, Dejan. That was really good talk, really good presentation. And my question is about the solar cells. How did the producing companies achieve such a big drop of the energy that they're using to develop those cells? And also, how about the recycling of the cells? This is a bit of an issue, maybe not today, but maybe in 20 years. Lots of elements can't be recycled, or it's not really viable to recycle them. So what about that topic? Do you know much about that? Or
Now, about producing the solar cells, why they achieve that, I don't know, because I'm not specialist in producing the PV solar cells. The curve itself, or the relation that the cost is dropping with how many units you produce, is something that is not seen for the first time in PV sector. So we saw that all over the different industries. So this is something that is quite of a common, and that's why this is, I would say, the power of technology and the power of smart people where we put effort in, then we can achieve a lot of improvements. The other side, or the other aspect of this, is nuclear, for example. Today, nuclear has problem because of their cost competitiveness. Okay? Why they have those problems? not because we don't understand nuclear energy, but we just don't produce them enough. So because of the issues which we all know in past decades, the number of installment of nuclear power plants lowered, and that's why also the cost stopped dropping, or it even increased. Why? Because new requirements for safety came in place, and this is actually, you know, the vicious cycle or the issue with nuclear. Now, referring to the recycling and the end of solar cells, currently this is not an issue yet. It is many times, you know, expressed as a main issue. I spoke with people who do that, and they said that they don't see this as an issue because the solar cells can be recycled. The technologies are not there yet, and again, maybe because the problem is still not so big. But you know, what I see is that sometimes such problems are not seen as opportunities or you know, just problems that we need to solve, but they are put in front by those who want to prevent development. The similar thing is happening with EV cars, where you hear a lot of different, you know, myths that, okay, lithium, cobalt, and so on, it will not be, and again. But this is, you know, I see it as a propaganda of those who gain if there is a delay in development.
I guess it comes to like some elements that can't be recycled today because of the big cost. Maybe it's going to drop in years or something. Now, just one more question about energy power plants. How do you see, like, probably nuclear is the way to go? Because at the moment we're still 1/3 is still coming from the coal in Slovenia, for instance. So,
yeah.
And the nuclear is slowly coming to the an end in Slovenia. So, I think what's your point on that? Like, do you think that the nuclear is definitely the way to go?
Yeah. Okay. My view on that is, I would point out one event which happened 2 or 3 years ago. There were two groups of scientists in America who, in peer review papers, one group was saying that by 2050, US could transition to 100% renewables, and the other group said, no, we cannot do that, at least not with reasonable spending of money. And they fight it so much that they even came to the New York Times and so on, and you know, it was all show at the end. But if you go and read those papers, you see that one group was saying, okay, we can transition to 100%, the other was saying, no, we can transition towards 80, maybe 85%, but that's it, we need to fill with other sources then. You know, from my perspective, my takeaway there is that from today's standpoint, we are away in a similar way to one and the other goal. So the path is totally clear. Now, whether we will come there or not, I'm not sure. And I also didn't see and read any, clear analysis that would prove that we can do it or not. So the path is totally clear. How far we will come, we'll see. For sure, nuclear is the answer, or let's say the missing piece. And if we then go to Slovenia, so what is our strategy? For sure, the strategy for Slovenia, at least as I see it, is that for next 10 years is totally clear. So for next 10 years, we don't have problems with the power sector because also of TEŠ that we just constructed. So that's why we need to invest our efforts into developing renewables, for sure, so that we see how far can we go and how far can we reach. And we must not prevent investing and keeping the knowledge that we have about nuclear, because we have a very successful nuclear power plant which has a lot of knowledge, which has experiences, and it would be the stupidest thing to throw that away, which some people try to do that. And I believe that in 10 years' time, we will need to, depending on how the things will evolve, we will need to decide whether to go for the second block or not. And actually, till then, we need to, to keep preparing also for that project, just to better manage our sustainability risk and energy sufficiency risk.
Okay, thank you.
Thank you very much for a good talk. My question is very short. How far we can go with implementation of renewable sources to the power grid without energy storage of next future generations? So
sorry, how far?
How far we can go with implementation of
renewables without energy storage?
Yes.
I believe that we already have quite good technology for energy, because we need different storages, okay? Let's discuss first this. We have two types of storage. One is daily storage, so that we overcome the difference between day and night. And then is seasonal storage, where we need to overcome the seasonality, so summer, winter. The daily storage is quite achievable. And for example, the Sustainable Energy Circle case, which I presented, it's already a proof of that with battery storage, which is already here, maybe it's not cheap enough, okay, but we have solution there to manage this daily seasonality. When it comes to seasonality, summer, winter, and since during the winter there is little sun, and if we want also, on the other hand, electrify heating, then here we have an issue. So I hope that our professor will go further with the invention, and that we will get solutions also for this seasonality storage issue.
Thank you for your explanation so far. I worked with e-mobility many years, and I have a question for you. Are there any projections how the e-mobility, which let's say will come on power somehow 2030, will impact European Union and world energy demand and supply?
Mm-hmm. Okay. If the rule of thumb or rough estimation is that if we transition with all cars, personal cars, okay, we are not talking about trucks and so on, from fossil fuels to electricity, the increase in demand is roughly 20%, okay? So 20% increase in electricity demand is not something non-doable. This is first thing. Second thing is that we will not transition all our electric car by 2030. So again, till 2030, and also with those simulations in terms of how we manage the EV charging, I don't see major issues. I mean, it's doable, okay? We need to make it properly, but it's doable. The second reason, or the proof also for that, is Norway. So I'm speaking a lot with colleagues from Norway, and when you speak with them and say, because they have a huge penetration of EV cars, and when you speak with them, okay, do you have problems in system? They're just saying, what? And there are maybe some, and they say there are maybe some parts of the town, residential parts, which had already before quite lower strength of the grid, and there we face some problems, but otherwise not. It is true that they have, 95% of production or 100% of production is from hydropower, and they can, balance it very easily, but they never put in front the problems with grid, never. Also, if you go at their conferences, they don't have a special session, okay, how to solve the grid problems and so on. They're tackling other issues and putting priorities. So from that point of view, I see the trend of electrification of transportation as a no-brainer. It will happen fast, and I think that next decade that we will just enter in will be very interesting from that perspective. Yeah. 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 Germany, it's a kind of a funny. Yeah? It's funny because from their Energiewende, so their energy transition perspective, it's kind of a strange that they're phased out first nuclear and only then coal. Usually I put a picture of a daily coal mine in Germany, which is, if you didn't see it, it's quite impressive. I also made a test from Google Maps. You know, if I see the whole Europe, I can pinpoint where those coal mines are, and then you zoom in and you see how huge these are. And actually, because of this phase out of nuclear, Germany will not meet targets for 2020. And if you listen carefully, when Angela Merkel began this current mandate, she said, okay, we will not meet targets of 2020, but we will improve and additionally lower 2030. Okay, this is 10 years later on, so no problem to, you know, to promise that. So Germany is a kind of a tricky. They also invested huge amount of money into renewables. So their production of renewables is quite impressive. They defined now the phase out of coal. I think it will end in 2038. And in terms of e-mobility, I think that there is a very strong presence of their current manufacturing industry. Now, their automotive industry in Germany is for sure one of those who are breaking transition to e-mobility. The biggest parts in the world where e-mobility started aggressively and with most invention was US and China, so Europe is lagging behind. Now Volkswagen is investing in, and they are saying now that, and they are, you know, full month of e-mobility. We will see whether this is already too late or if they will catch up, we'll see. But in Germany, for sure this trend will come behind, but I don't see that, again, I don't see that e-mobility will make such a big problem. I think, you know, that, for example, already the differences between production and consumption, because they have majority of the wind on the north and majority of the demand on the south, and that's why they have a huge flows from north to south, which flow not only through Germany, but also from other countries, Poland and so on, and produce quite a lot of issues, is that those effects to the grid are higher than just electrification of transportation. I don't see the charging as such a big issue. It is an issue, but doable.
Any more question? Otherwise, I would conclude this with one of my questions, just one. So recently I was listening some people from Japan. Japan wants to be zero carbon country, everything on electricity, but they still want to drive the cars and buy the batteries and buy the parts and buy the material for windmills and so on. So it seems to me that they just want to keep their country clean, while all dirty jobs, you know, to be done somewhere else,
Yeah.
to be done in South Africa, to be done in South America, or so on. So for me, global-wise, that's not a big of improvement.
Yeah, it is true. You know, the whole global situation is tricky. That's why it's quite important that we look at the global data, and the global data are not promising. So if we look at the global data of energy consumption and how the things are evolving, still we didn't change the trend, so the trend is still worsening the whole situation. Japan has the problem of phasing out the nuclear power plants due to Fukushima, so they stopped their all power plants. They switched to gas mainly, LNG, and that's why also affected the whole situation on gas market with that. for sure, you know, I think that this is not only Japan problem, but also of other modern societies or developed societies that, you know, speaking something and then doing somewhere else the dirty job. And this for sure, you know, it's not helping the planet, for sure, because the CO2 emissions don't know borders.
Just one related question. Namely, one German institute has performed like a full life cycle analysis of the electric cars versus classical cars with respect to the carbon emission. And the result was that there's not much difference in the whole life cycle, taking account the sourcing of the metals for the batteries, recycling, and of course electricity that is consumed by electrical car. How you would
this is, again, it's similar thing to the recycling of PV modules. There are different, again, different stories, different studies, and so on. I didn't look at them in detail, so I cannot comment them, but I'm taking them with small, you know, reserve, especially because there I see a very, very strong interest that every day transition is delayed. There are millions that some companies are gaining. Yeah? So from that point of view, there is a lot of mispropaganda for sure. And secondly, also if something is not working probably now at the beginning, again, we need to, you know, evolve it to a certain point. I mean, it would be silly to say, no, we will not transition from fossil fuels because, you know, the technology is not working properly. One of such cases is, for example, the electric cars taking fire. Yeah? You know, when Tesla takes fire, all newspapers are full in. Mr. Peciak from Metron Institute is always explaining this in his presentations, that I think that 1 or 2 cars are taking fire in Slovenia per day, every day, you know. And then also it has a picture on highway when a normal car took fire, you know, there is smoke which you can see it from 100 kilometers, you know. And again, but all those pictures don't come into the media. So for that reason, certainly there are issues and problems. We need to tackle it, but there is no doubt that we need to transition away from fossil fuels.
Oh, one more for the end.
So energy density of the batteries, it's a problem today, no? So, it's 14 times lower than 1 liter of, or 1 kilo of diesel fuels. So is it doable that this problem will be overbridged with science? Or do you believe in that?
Yeah, I don't know. Yeah, for sure density is an issue. Now when it comes to the storage for the grid, it's not an issue anymore because we have there enough space. But when you need to take with you that storage, then it is an issue. This is the same issue as it is in airplanes because they spend a lot of energy just for taking, you know, the fuel with them. So the same thing is with electric cars. But I was reading one debate, and actually, you know, if we increase the density, and with that goes also with lowering of the cost, but the magnitude of 2 or 3 or something, you know, we come to a pinpoint that actually already the new car, electric car, will be cheaper than the normal car, while the variable cost of the car, anyhow, of electric car, is much lower. So, you know, I don't think that we are that far away, because already today the electric car itself is cheaper if you look at the total cost of ownership. If also the investment, so the initial price, will be same or lower, then that's why I'm quite confident that I think that there is no turning back from that path.
So Thank you very much. I think we can
Thank you.
conclude with this scientific evening. Thank you for your visit here and, of course, for your efforts to explain all these issues to us.
Thank you.